The HDR200 is an indicator and 4 to 20 milliamp loop powered transmitter used for measuring moisture content in air and other gases. It's reliable, accurate, and easy to use, but what makes it unique is that its probe can be mounted and operate in gas temperatures up to 200 degrees Celsius with pressures up to 750 psi. The HDR200 can be configured by the user for either dew point temperature measurement or relative humidity measurement. Changing from dew point to humidity is simple and only requires changing an internal dip switch. However, for the user's convenience, IO sells the HDR200 pre-configured for either dew point temperature measurement under the part number HD200 or humidity measurement as HR200. Later in this video, we'll show you how easy it is to switch from one measurement to the other. For the purposes of this video, we'll refer to the device as the HDR200, but the actual part number used when ordering would be either HD200 or HR200. The HDR200 includes a stainless steel probe, a compression fitting for mounting the probe, and an electronics unit that provides a display of the measurement. The electronics unit also has a 4 to 20 milliamp output that is a retransmission of either the humidity or the dew point temperature. The HDR200 also comes with a NIST traceable calibration certificate. The measurement capability of the probe is really what makes the HDR200 an exceptional device. It has the ability to be mounted in environments with temperatures up to 200 degrees Celsius and pressures up to 750 psi. Very few humidity or dew point measurement instruments on the market can handle that level of temperature and pressure. This makes the HDR200 a great choice for applications involving compressed air, dryers, and environmental chambers. The probe length is 6½ inches, but the compression fitting allows the probe to be extended to different lengths into the process by sliding the probe through the fitting until the desired length is reached. Once the desired length is reached, you can tighten the compression fitting onto the probe, locking the probe in place and creating a pressure-tight seal. The probe is connected to the electronics unit by a cable 1 meter in length. As a special order, we can provide the HDR200 with a longer cable length up to 25 feet. Please contact IO Thrifty for more details. The electronics unit has a dual display. When configured for dew point temperature, the display will show both the dew point temperature and the temperature. When configured for humidity, the display will show both humidity and temperature. We'll power this one up in a few minutes to show the display. The HDR200 is also a 2-wire loop powered transmitter, which means power and transmitted signal travel through the same 2 wires. We'll show exactly how this works later in the video, but let's start by powering up this unit to show the display. The red wire is positive and the black wire is negative. Although the standard wire length is 12 inches, the wire can be extended by the user by just splicing additional lengths of standard signal wire. The HDR200 is powered by 12 to 28 volts DC power. For this demonstration, we'll use an adjustable power supply, which allows me to make a quick temporary connection using clip leads. But for a more permanent installation, IO Thrifty also sells low-cost power supplies like the PSJ-R, which converts AC to DC voltage, plugs into a standard AC outlet, and provides screw terminal connections for its DC voltage output. It's a good low-cost accessory to purchase along with an HDR200 if you don't have DC power readily available. Now I'm connecting the HDR200 to my power supply, which is set to put out 24 volts DC. As soon as the power is applied, you can see the HDR200 turns on and displays both dew point temperature as well as temperature. Since this is an HD200, it shows dew point temperature. If it was configured as an HR200, it would display humidity instead of dew point temperature. We'll show you how to switch it over in a few minutes. If you're using this for display purposes only, there's nothing else that needs to be done. But the HDR200 also has an analog output that retransmits the measured value as a 4 to 20 milliamp signal. When the display is set for humidity, the 4 to 20 milliamp output will equal 0 to 100% relative humidity. If the display is set for dew point temperature, the 4 to 20 milliamp output will have a default factory scaling of -60 to 40 degrees Celsius dew point temperature. The full range of the HD200 is -60 to 100 degrees C, which is the range of the display. If you'd like the analog output scaled differently, please let us know at the time of ordering, and we'd be happy to scale it to your specified range. Now I'm going to demonstrate the 4 to 20 milliamp output. As mentioned earlier, the 4 to 20 milliamp output is a 2-wire loop output in which power and signal travel along the same 2 wires. Here's a simple diagram showing the HDR200 connected to a power supply and an instrument to measure the 4 to 20 milliamp signal. The circle with an A inside it represents a milliamp meter, which could be a panel meter, a controller, a data logger, or any other instrument that can read a 4 to 20 milliamp signal. In this diagram, the milliamp meter is wired up between the negative of the HDR200 and the negative of the power supply. We could also wire it between the positive connections as shown in this diagram. For this next demonstration, we're going to connect the HDR200 to an N1540 panel meter. The N1540 is a low-cost panel meter that can accept signals from thermocouples, RTDs, and other sensors or devices with voltage or 4 to 20 milliamp output. I've chosen the N1540 for this demonstration since it also provides 24 volts power, which we'll use to power the HDR200. In this demonstration, the N1540 is located right next to the HDR200, but in a more practical application, the N1540 could be located hundreds of feet away. The HDR200 comes with 3 feet of cable that can be extended in the field with just ordinary copper wire. This diagram shows the wiring between the N1540 and the HDR200. Because the N1540 provides 24 volts DC power, we no longer need the power supply that we used in our last demonstration. Here we now show the N1540 and the HDR200 working together. You may notice that the dew point temperature is lower than the last time we powered up the HDR200. That is because this portion of the video was recorded on a different day. Prior to connecting the two devices, I configured the N1540 for 4 to 20 milliamp input and set the scaling for 4 milliamps equal to minus 60 and 20 milliamps equal to 40 degrees Celsius to match the default scaled output of the HD200. I mentioned a few times earlier in this video that several of the configuration options of the HDR200 could be set by internal dip switches. Here you can see I removed the 4 screws holding the HDR200 cover in place to show the location of the dip switches. The red switch block actually has 2 switches. The one on the left is for changing the reading from dew point temperature to humidity and vice versa. The switch on the right is for setting the temperature units of the display to either degrees Fahrenheit or degrees Celsius. This will affect both the temperature and dew point temperature. I'm going to change the leftmost dip switch, and after applying power, you can see that my display, which was previously showing my dew point temperature, is now showing relative humidity. If I now change the switch on the right, my temperature reading will change from degrees C to degrees F. Before concluding this video, I wanted to mention 2 additional items. The first is that we also offer a version of the HDR200 with an M12 connector instead of the wire leads that are on the unit that we've been demonstrating. The M12 connector makes it easy to quickly connect or disconnect the HDR200, but it also provides access to not only the 4 to 20 milliamp loop, but also RS-232 communications. With RS-232, you can read dew point temperature, relative humidity, and temperature from a computer or PLC. And the final point I want to mention is that although the HDR200 can read up to 200 degrees C, it must be a non-condensing environment, since condensation can damage the sensor. However, if you have a condensing environment, IO-Thrifty may have a solution for you. Please contact us and we'll be happy to discuss your application. Thank you for watching this video. Feel free to reach out to us with any questions or comments.